Let's solve this integral here. How do we start? Now right away, I can factor out the x here in the denominator. I guess I can cancel out the x in the numerator, right? So let's do this. Integral of x over now x times 1 plus ln x square dx. Now the x and x can cancel out. What we have left is integral of 1 over 1 plus ln of x square dx. It looks simpler. What do we do next? I think I will use some substitution method first. Okay, so I will let k equals to ln of x, and dk is equal to 1 over x dx. Now, what would that give me? Multiply x to both sides. I have dx equals to x times dk. Okay? Now, let me rewrite this integral now. That's equal to integral of 1 over. Now, because I will replace dx with x times dk, so the x can go to the numerator. Okay, so here, I can just put x here. Now, over here, 1 plus k squared now. That would be 1 plus k squared times dk, right? Yeah, x times dk is dx here. Now, we have to have everything in terms of k right now. So we cannot have the x here. How do we write the x? Now we know that k is equal to ln of x, right? So from here, k is equal to ln of x. Now I'll take the exponential of both sides, like e to the k, e to the ln of x. Now this is just equal to x, right? So e to the k is equal to x. Now I can replace x with e to the k, right? So that is integral of e to the k over 1 plus k squared dk. Okay, now how do we integrate this? Maybe we can try to factor 1 plus k squared, right? Because this is k to the power of 2. If it's k to the power of 1, it may be a lot easier, right? Maybe I can rewrite this like that. Integral of e to the k over, now, k squared plus 1 dk. Okay, now, how do we factor k squared plus 1? It will be easy if it's k squared minus 1, right? Because that's just a difference of square. But not really, this is plus. So what do we do? Now, to factor k squared plus 1, we have to bring in the concept of complex number. So let's talk about this. Okay, so we're talking about complex number here. Now, square both sides. We have -1 equals to I squared. Okay, now, to factor k squared plus 1, right? Let's look at this. Now, k squared plus 1 is also equal to k squared minus -1, right? You can see it like this. That means here, -1 here is equal to I squared. So we can see this as k squared minus I squared, right? Now, this is minus here, which we can factor by difference of square. That will be k minus I times k plus I. Okay? Okay, so this one here, let me separate this. So I can rewrite this integral as e to the k over k minus I times k plus I dk. Okay, now what do we do? Now, looks like we can use partial fraction decomposition on this, right? So that we can decompose this denominator, then it will be easier, right? Okay, let's do this. 1 over k minus I times k plus I, okay? Let's try to decompose this. And that's equal to, let's say, a over k minus I plus b over k plus I. Since all the k's here are to the power of 1, okay, so we can just do it like this. Now what do? We want to find the common denominator, right, for both of this fraction, and then group this together, right? Okay, so here, for this one, it will be a times k plus I, right? So that we will have k minus I times k plus I, right? Plus b, this one will be multiplied by k minus I, right? So that I will have k minus I times k plus I, okay? Now, since we have the common denominator here, we can just group this together, okay? So since we group it together and both sides have the same denominator, that means the numerator on this side equal to the numerator on this side. So here, 1 is equal to a times k plus I plus b times k minus I, okay? So we can equate the numerators. Okay, so here, 1 is equal to, now distribute a and b, right? So that's ak plus ai plus b times k minus b times I. Of course, we have to group the like terms together, right? So 1 is equal to a times k plus b times k plus a times I minus b times I, right? Now, because k here is a variable, right? So we will factor out the coefficient. So a plus b times k plus a minus b times I. I is a number here. Okay, so this is a variable, this is a number, and on this side we only have a constant 1. So that means this term must be 0. So we can say that a plus b times k is equal to 0. And a minus b times I is equal to 1. Now we have to calculate a and b. Now right away we can say that a plus b is equal to 0, right? Divide both sides by k, we get that. That means b is equal to negative a, because we just subtract a from both sides, right? Now we can replace b here with negative a, so we have a minus a times I is equal to 1. Now this will become plus, right? So a plus a times I is equal to 1. Now this is 2a times I equals to 1, right? What is a equal to then? Divide both sides by 2i, so I have 1 over 2i. Now that's a. What is b? B is just negative a, right? So b is equal to negative this, 1 over 2i. Okay, so we find the value for a and b. So we can put it back here, right? So this integral okay, let's bring this integral to here. And we were trying to decompose this one, right? So we were trying to decompose this one. Okay, and we got that. Integral of e to the k times, now, the first term, first fraction, is a over k minus I. Okay, so a is 1 over 2i. So here, right? One over 2i divided by here k minus I plus the second fraction b over k plus I, and b is equal to negative 1 over 2i. So the second fraction. Negative 1 over 2i over k plus I. Now dk. Okay. This here, right? We can just bring it down here, right? The minus sign. Okay. So that's minus. Now, notice that 1 over 2i is just a number. So we will bring it out of the integral sign. And then bring e to the k to the numerator here. So 1 over 2i integral of this, right? E to the k over, now k minus 1 minus e to the k over k plus I dk. Now, let's break it down into two integrals, right? So 1 over 2i integral of this minus 1 over 2i integral of this. Okay, now we have to evaluate these two integrals here, right? This one and this one. So how do we do this? Well, I guess I will use another substitution method, right? I already used the letter k. Let me use u this time. Okay, so let me do it here. So let's do this one first. Now, integral of e to the k over k minus I dk. Let me use letter u this time, right? U is equal to this one, k minus I. I is equal to square root of negative 1, right? So it's a number. So k is a variable. So differentiate u with respect to k. I have du equals to dk. Okay, to do that, I can replace the denominator with u and dk with du, but there's still a k here, no problem. So this one here, right? K is equal to u plus I, right? We add I to both sides, so we can replace it like this. So this one here will become this. Integral of e to the u plus I over, that will become u du, right? Okay. Now we can use the property of exponential here and rewrite this as integral of e to the u times e to the I over u du. Now, again, I is a number here, right? So e to the I is a number. So I can bring this out of the integral sign, right? So e to the I integral of e to the u over u du. Okay, so what's the integral of e to the u over u du? It is basically this. The exponential integral of u. Now, let's see, right? Constant. Okay, in this case, u is equal to k minus I, right? So I will replace u with k minus I here. So e to the I times exponential integral of k minus I plus c. Okay, now let's look at the second integral here. E to the k over k plus I. Here. Integral of e to the k over k plus I dk. Again, use substitution method, but I will use a different letter this time. Let me use w equals to this, right? K plus I. Then dw is equal to dk. Now again, here, I have to replace the k here too, right? So that is equal to, now k is equal to w minus I, right, from here. Okay, so this integral will become integral of e to the w minus I over, that is w now, and dk is dw. Okay, using the property of exponential, right, I can rewrite this as, now notice that this is same as w plus negative I, right? So that's the same as e to the w times e to the negative I, right? Over w dw. Now, this is a number. I can bring it out of the integral side. So that is e to the negative I integral of e to the w over w dw. Now, this is the same form, right? So, the answer is exponential integral of w plus c. And w is equal to k plus 1. So I have to replace it into here. K plus I mean. Okay. So I just evaluate both of this integral here, right? So I can write this now. That's equal to 1 over 2I times, the first one is this, e to the I times exponential integral of k minus I. We will leave the plus c here. Okay, minus 1 over 2I, this one, right? Times this. E to the negative I times exponential integral of k plus I. Okay. We can add c here, right? Because we're done, but we don't want to write everything in terms of k, right? So let's go back to the original integral. What was k equal to? K was equal to ln of x. Now, we place ln of x into k here. Okay, now we are done. So this is the integral of x over x plus x times ln of x squared. Hope you enjoyed this video. Don't forget to subscribe to my channel. Thank you.